equation, we are told that P plus Q plus R is equal to 5 and PQ plus QR plus PR is equal to 3, where P, Q and R are positive real numbers. We are required to calculate the largest value that P can take. So we are given two equations and three variables. So first thing we'll do is we'll eliminate one variable and then we'll have one equation in two variables and then we'll try to maximize the value of one of the variables. So in this particular case, let us first try to eliminate R. P plus Q plus R is equal to 5. So the value of R is equal to 5 minus P minus Q. Next we have PQ plus QR plus PR is equal to 3, or PQ plus R into P plus Q is equal to 3. We have already expressed the value of R in terms of P and Q. So what we'll do is PQ plus P plus Q into R. So P plus Q into 5 minus P minus Q is equal to 3. So this would imply that PQ plus 5P plus 5Q minus P square minus PQ minus PQ minus Q square is equal to 3. We have just expanded the bracket, we have multiplied all the terms with each other. So we can cancel PQ, one PQ over here and one PQ over here. So P square plus PQ plus Q square minus 5P minus 5Q plus 3 is equal to 0. This is a quadratic equation in P, this is a quadratic equation in Q. Let us try to make this a quadratic equation in Q first, and then we'll use the fact that Q is a real number to calculate the maximum and minimum values of P. How are we going to do that? We'll write this as Q square plus Q into P minus 5 plus P square minus 5P plus 3 is equal to 0. Essentially, we have segregated all the terms which have Q square, which have Q and which don't have any term of Q in it. So this is a quadratic equation in Q, and we know that Q is real. If you have a quadratic equation which is of the form ax square plus bx plus c is equal to 0, and if you are told that x is real, it would imply that the discriminant d is greater than or equal to 0. What is the discriminant of a quadratic equation? It is b square minus 4ac. This has to be greater than or equal to 0, where b is the coefficient of x, a is the coefficient of x square, and c is the constant term. So in this particular case, what that would imply is that p minus 5 whole square will be greater than or equal to 4 times p square minus 5p plus 3. So let us try to expand this. It would imply that p square minus 10p plus 25 is greater than or equal to 4p square minus 20p plus 12. So this would imply that 3p square minus 10p minus 13 is less than or equal to 0. So this would imply that 3p square minus 13p plus 3p minus 13 is less than or equal to 0, or p plus 1 into 3p minus 13 is less than or equal to 0. So the value of p will vary between minus 1 to 13 by 3. These are the two roots of the quadratic equation p plus 1 into 3p minus 13. What are the two roots? It would imply that either p plus 1 is equal to 0, which would imply that p is equal to minus 1, or 3p minus 13 is equal to 0, which would imply that p is equal to 13 by 3. These are the two roots of the given quadratic equation. We are told that the value is always less than or equal to 0. So the value of p will lie between both of these roots. So p will vary between minus 1 to 13 by 3. So the maximum value of p is equal to 13 divided by 3. This is the answer.